Okay, hi guys, we're here to talk about 3.3 notes, which is continuous functions. So we talked about discrete functions, that's where everything was listed and everything was disconnected. Now we're talking about continuous data, which is data that is connected. Okay, and the numbers in between matter. So this is where we're actually going to have fractions. Okay, and then on a graph, it's actually going to be a line or a curve. So remember, this means we can have fractional pieces. So if we're looking at the graphs below, we're going to circle all the ones that are continuous. So the number of children in a household. Now you can't have a fraction number. Of kids, so that's obviously not continuous. But time in a race, so time when you start a timer is just going to keep going and you show all those fractions of a second. This is continuous because it's connected, it has a curve. Okay, the height of children, that also is continuous because you could have a fraction of an inch or a fraction of a foot. Number of apples, you can't have a fractional number of apples growing. And this right here is not connected, so it's not continuous data. So when you're looking to try and figure out your domain and range, so with domain and range for discrete, we were just listing. Well, domain and range for continuous is not like that. We actually had to find a list, not a list, but an actual set of numbers in a bracket, an inequality, to figure out which one are our x values, which is still our domain, and our y values, which is our range. Okay, so the main thing you need to know about domains is we're measuring from left to right, and the range is bottom to top. So a little acronym to help you is DOLAR, the robot. So domain, left to right, range, bottom to top. Okay, so we're going to actually be measuring those. So using an open circle, so when we did inequalities, we talked about open circle and closed circle. So when we had just our regular less than or greater than symbols, we had that open circle. And if they had the line on the bottom for the equal to, then we have a closed circle. So those are coming back to our graphs. So if I were looking at this picture right here and I want to figure out my domain, so it says domain is left to right. So I'm going to take my highlighter and I'm going to show you the far left side and the far right side. Okay, now domain has to do with x values, so we're looking at our x values, which is where it hits, so -3 and 3. So I'm put -3 is my first number left, +3 is my second number on the right. So this came from the left and this came from the right. Now it's the same thing with my range, except I'm doing bottom to top. Bottom number, my very bottom part that's used, and my top is my very top that's used. So my bottom is -3, that came from the bottom, and the top, which is my +3. Okay, so I like to use markers when I do this because it makes it a little easier. You're more than welcome to not use markers, but it does actually help when you're actually trying to write your numbers out. Okay, so there's your first page. We're going to go on to the second page. This is where we're going to work some examples of how to find domain and range and how to write those. So your inequality symbol in the inside actually has to do with what type of dot you're touching when you do them. So remember, domain, $, robot, $, robot. Okay, so that tells me domain is left to right, robot, range is bottom to top. So we remember which goes first. So if I'm looking at my domain and I'm doing left to right, I'm going to draw it with my markers, the left side to the right side. And it has to do with x values, so I'm looking on my x axis to figure out what my values are. So this value right here is a -4, that's my left side. This value right here is a 1. So there's my numbers. Okay, now we're talking about domain, which is x's, so x goes in the middle. Now we look at our dots on our graph. See, this is going to be a closed circle, so it's going to have the line under it. This is also a closed circle. And all of your symbols are going to open to the right. Okay? They're always going to open to the right. You just need to decide if you need a line under it or not. So range has to do with bottom to top. Bottom to top. So if I look at the bottom value, I've got a -2. Top value is a +3. Okay, now I put a y in the middle because it's range. I'm measuring my y values. Okay, they both have closed circles, so they're both going to have a line under them, and they're open to the right. Okay, so as long as you can remember your signs are always open to the right, that will help. Okay, looking at this one. Okay, remember domain has my x's, and it's going to go left to right. So far left side, far right side. Okay, let's look on our x-axis. So we've got 0 and 5. So 0 and 5 are my numbers. I am measuring x values. Okay, this is a closed circle, so it's going to have a line. This is an open circle, so it has no line. But my inequality symbols are always open to the right. Same with range, except I'm doing bottom to top. So I find the bottom of my graph that they did and the top of my little squiggly line that they did. And I'm going to get my y values. So I've got -2 is the bottom and +3 is the top. I'm measuring y, so y goes in the middle. Okay. And then the bottom has a curve, okay, and it's going to actually touch that, but the top, it also has a curve, so it's going to also touch that. And we want to go through and put our symbols with our lines under it because it's actually going to touch that. Okay, this one, you're lucky it didn't print my graph line, so we get to omit that one. Okay, but looking at this one, so remember, domain is left to right, left to right. Now, what you haven't had in another one is these have little arrows on them. Okay, when you have a line that has arrows on it, it means it keeps going. That means past my line, past the graph, it's just going to keep going. So that means we have what's called all real numbers. Okay, if you were going to write that as an inequality, you would have -infinity to +infinity with your x's in the middle and your inequality symbols. Either one of these would be perfectly fine. Most people just want to write all real numbers, so they don't have to do that little squiggly for your inequality. Okay, bottom to top. Okay, we're going to do our range, bottom to top. Now it does have a top value, but the bottom value is my -infinity. Okay, it just keeps going. And my top value is a 4. So I put my y in the middle. I have my inequality symbols. Okay, now you don't have to ever put this part on here. You could have actually just said that y is everything that's less than or equal to 4. That would have been perfectly fine. Y is less than or equal to 4. Okay, so now we're going to look at this bottom part. We're talking about functions as word problems. So this first one says the function of t equals 9m plus 65 represents the temperature in degrees in Fahrenheit of an oven preheating for m minutes. So we've got temperature is our t, and m is our number of minutes. Okay, so we're going to identify the independent variable and the dependent variable. So dependent means it depends on the other one, and the independent means that it's on its own. So in this case, my m, which is my minutes, is my independent, and my temperature depends on how many minutes it's been heating up, so my temperature is my dependent. Okay, the recipe calls for an oven temperature of 350, so we want to describe the domain and range of the function. So we're going to substitute in 350 for our y, and we're actually going to look at what that looks like. So my temperature, okay, remember, it's going to depend on what it is. So we want to start at my basic start function. This right here where it says plus 65, that means that's how warm the temperature is when we start heating up the oven. So that's just their beginning time. So 65 is my lowest temperature. 350 is my highest temperature. Okay, we're measuring our y's, which is our temperature, and then we're going to have both of our signs open to the right. Okay, now if you're talking about your time that it takes, we have to start at 0 minutes. Okay, we have x, and we have to figure out how many minutes it's going to take for us to get to 350. So we're going to actually substitute 350 for t. So I'm going to do that over here on the edge. So we have 350 equals 19m plus 65. Okay, and we're going to actually solve for m. So we're going to subtract our 65. Okay, that gives me 285 equals 19m. And when I divide by 19, I get 15 minutes. So my upper side is 15 minutes. And then I put both of my signs in facing outward to the right. Okay, we're going to go ahead and skip the last one. If you want me to work through that one just because you're curious, you're more than welcome to hop into office hours. Okay, but I hope you have a good day.